Alright, so we ended the previous set with the sonic boom. Here's another video. This one does not have sound, but it shows that the pilot was trying to fly right at the speed of sound. You can see that it actually broke it twice. So right there, and then slowed down a little bit, and then again, you can see that cone forming. Why does the cone form?
Because of
the pressure. No, it's yeah, it's a cloud. Right? It forms a cloud. All right. So moving on to interference. So there are two types of interference. The first is destructive. So destructive, you have two waves, okay, that you add together. Now this is exactly what you did during the matching waves activity, the wave match game. What you were doing is you were creating interference to match those waves. Destructive, if you notice, these are mirror images of each other, where the crest is matching up with the trough. Right? They're mirror images. Now when you add these two together, what happens? Destructive, what can you glean from that?
That will destroy the wave.
It'll destroy the wave, and what we get?
Some kind of line.
Yeah, you get nothing. They cancel each other out.
Oh, okay.
So these are out of phase. Sorry, this. Those waves are out of phase with each other. Okay, if they were in phase, it would look
harmonic.
like that, right?
I know. That's what it is.
Okay, see how these are opposite? Okay, so that's destructive. What do you think constructive is going to be?
It's harmonic.
You can
correspond to each other.
Make it better.
They're exactly the same.
Okay, they're exactly the same. And what's going to happen?
That's the same.
Same way, but what?
More powerful.
What is bigger?
Amplitude.
The amplitude. That's right. Now this is exaggeration, but you get the point. So destructive, it cancels. Constructive, it builds. So what would you say about phases for constructive?
It would be
In phase with each other, that's right. In phase. So the next slide has an animation. Showing these two waves. So you have the top wave and the bottom wave. The blue line is the two waves added together, right? The summation of the two waves. So notice right there, it's constructive, right there, destructive. So constructive, destructive.
Why is that?
The two. This first one represents the top wave. The second one represents the bottom wave.
Why is it the same?
What do the dots stand for? It's just the one stands for the top wave.
First one stands for the top wave. The second one represents the bottom wave.
Oh.
So that's out of phase, and then in phase, right?
Oh, because they're matching. Right?
That's right. Out of phase when they're opposite each other. Out. When they're matching. In phase. All right. Resonance. Now resonance, just like constructive interference. So if you have two vibrations and they occur in phase with each other, then they're going to produce a bigger vibration.
Does this have anything to do with an echo?
An echo will just be one source. No, this has to come from two sources.
So this is like if two people are yelling the same thing at the same
time. In this case, we're not necessarily dealing with sound. Okay, this is any kind of vibration. I'll show you what I mean in a second.
Does like water work the same way when it comes to like at the lake, you know, you'll see water and it'll start out at first and in the past it'll be a lot bigger.
Yes, that is exactly.
It'd be kind of like a string. Like string.
Oh, I get it. Oh,
sure.
Okay.
Think of it like that. So here's an example.
This bridge was exceptionally long and narrow, over half a mile long, only 39 feet wide. It lasted just 4 months.
That sucks.
During construction, we see the steel girders, 8 feet tall, which were supposed to stiffen the bridge against bending. However, some up and down vibration was observed during the entire useful life of the bridge. Here's opening day. On November 7th, the bridge suddenly went into a twisting motion. The wind speed was a steady 42 miles per hour. This was enough to keep the bridge oscillating in one of its natural modes of vibration, with a period of 5 seconds.
Right? 5 seconds, period. So what does that mean? That's back and forth, right?
Yeah.
So what is the frequency going to be?
A professor of engineering went out to see what had happened.
1/5.
He's coming back, walking with some difficulty along the nodal line.
No, the bridge is not decided. I mean, it's decided to move, but remember that's concrete and steel.
If you fall asleep.
No, the bridge is on the move just now. I'm something like 150.
This would be so crazy, bro.
I would like
It's remarkable that the girders were this flexible. This is photographed at normal speed. However, the collapse was inevitable after a little more than an hour of this.
Once now.
The car had been abandoned earlier. No one was injured in the whole affair. However, a small dog in the car was frightened and was afraid to come out. and he perished along with the bridge.
Why did nobody save him?
Because no one was crazy enough to pull him. Actually, one try.
The bridge was rebuilt using a stiffening truss instead of girders. The new bridge is completely stable.
How long did it keep falling and falling?
I don't know. Alright, that's residents. Moving on. Using technology. Sonar. I guess technically sonar should all be capitalized because it's an acronym.
Yeah.
But sonar was responsible for us being able to map the ocean floor. Useful in World War II during the fight for the Pacific.
Yeah, find the German submarines.
Yeah. Yes, you type.
I have a question over that video.
Okay.
I'm like, what caused it to happen? Like,
The wind. The wind was catching the side, and it was just kept on forcing it. It was basically just like a swing, right? Every time it would go up, the wind would push it back, and it just kept on.
But it looked like only the tar, or like the road was coming off.
It was just that middle section that was real flexible.
what happens if you like jump on it?
Did you go
Did they not think to get the dog out?
Sonar. So here's a real simple animation. We have a sonar buoy being pulled behind. It is producing a sound, and then it's recording when that sound bounces back. Since we know the velocity of sound in water, right, depending if this is saltwater or freshwater, we know the velocity. The time, however, is from when it hits the bottom to back up, right? So it's measuring when it's released to the bottom, back up. So what do they have to do with the time? Divided by 2, right? Because they just want to know from the sonar to the bottom. Of course, modern sonar, it does all of that for you.
But what if there was like a rock where you were?
Do they do this to see how deep it is?
Uh-huh.
But what if there was like a part where it was like this and then went down so you hit the
Sound wave.
I've been on
Well,
a
then
boat.
the next one will be just a drop off.
What's really cool is that it also catches debris and fish. My dad has a fish sonar.
Yeah, fish finder.
Fish.
Same thing. Yeah.
That's horrible.
Max, question?
Yeah, like, is that why when they, all the depictions of submarines is that noise?
The pinging noise? Yes.
Yeah, it's all the stuff.
That's it. Another very simple use of sound is figuring out how far away a thunderstorm is, right?
Oh, it's 3 seconds after, isn't it? Oh,
So we can figure this out mathematically. How fast does sound travel through air?
343 meters per second.
Okay, 343 meters per second. How many meters in a mile?
1600.
1,600. So 1,600 divided by 343 equals about what? 5. Right? So that means that it takes sound 5 seconds about to travel 1 mile. So when we see lightning, then you can count by fives before you hear the thunder to see how far away that thunderstorm is, at least where that lightning hit. Okay?
1, 2. Mr. Hansel, why is it more dangerous when the wave goes like that on the bridge than when it just goes up and down? Because I was on a bridge where the bridge would go up and down. It was over a really big bridge.
Well, a lot of that is taken into account, right? But if it twists, then it's bending all those parts where it shouldn't. A lot of them have standards where it goes up and down. I mean, the same thing if you drive over the, I-40, 235 junction, that whole thing like moves as well as you're going over it. I mean, there's tolerances. Also, they expand and contract with the weather. That's why if you look at a bridge, there are those metal, like big metal teeth that are some distance from each other. That allows the bridge to expand and contract. Hotter it gets, obviously it expands, so the whole thing doesn't buckle. And in the wintertime, when it's cold, it contracts. Echolocation, nature sonar. Bats use it to be able to fly through the cave, dark cave also. They will find their food. If you've ever seen a bat catch a moth or a mosquito or something in midair, a lot of cool slow motion videos of, they don't catch them in their mouth. What they do is you see their little flap of skin between their back legs. They'll fly over, we'll figure out where the moth is, and intercept it and catch it in that little pouch. And then it kind of folds in on itself and then grabs the little snack, whatever it happens to be, out of the pouch that is in between its 2 legs.
Is that because it can't detect the sonar fast enough to get it caught in its mouth, so it has to get rid of that?
Well, think about is it easier to catch something in your mouth or in the basket? Yeah, it's just going to increase your probability of actually catching it, right? If you have this area or just this area, it's just a lot easier to catch. So Chase, what?
Did you hear about there's like a blind dude and he makes it click with his tongue and he can like see objects?
Yeah.
At Sheldon High in Sacramento, 14-year-old Ben Underwood is a freshman like all the rest. Well, not exactly. In his first week, many of you haven't guessed that Ben has a secret. And you probably couldn't figure it out watching him in combat at karate class, or hitting his mark in a pillow fight, or zipping down the street on his rollerblades.
Did you lost your eyes? I was cleared 2 weeks before my 3rd birthday.
Ben had cancer in both eyes, but he discovered a way to beat his blindness.
I thought it clicked that way. I was like 6 years old.
He realized the clicking sound he made with his tongue bounced off things around him, giving him an idea that was there. Was it like seeing again?
Pretty much, yeah.
Ben says he can distinguish where the cars are as he cruises his neighborhood streets. Even though he can't see the basket he's aiming for, by listening for the distinctive echoes each makes, he can find the full and backboard on a basketball goal and sink a basket.
It becomes easy to forget that Ben is blind.
How's that?
How else to justify my pleasure when I put a couple of goals past him? You thought you were so good.
I am that.
He is indeed. Ben beat me 5-2. Taking a walk with Ben, I was amazed at what he can see with his ears.
Well, there's a fire hydrant on the side and a car on this side. Like, is that not a trash can or hold on, let me see. That's a trash can. Yeah, or recycling is one of those.
Playing video games with his brother Isaiah in the assault of noise. Then he can figure out everything that's happening just by listening. How can you even separate the sound?
Because they got different voices. Nobody is going to tell him that there is an impossibility for him because there are none.
It doesn't give you any breaks because you're blind, does it?
Nah. Why should he get a break? I can't get a break.
His mother offered at a girl he should have every opportunity, but no, didn't. But he's blind.
No, sir. I mean, you know, to society he's blind, but that doesn't make him handicapped. He just can't see.
Ben has much the same talent as the dolphins he visited at SeaWorld. The ability to use echolocation, returning sound waves to sense his surroundings. Quick's even told him to step around a fallen crash. I don't know how you do that, but the secret to that goes beyond other tricks. The net has always told him to keep anywhere.
Once he said to me, he said, Mom, yeah, I'm trying to see. Well, Ben, what you can do? I said, we have a blackout right now. Everybody has to follow you. Why introduce you to Ben? We need you to please hold it.
Don't sperm whales use echolocation? Like theirs is so loud, it's like made them the loudest animal on earth.